Hi, y'all. Good afternoon, y'all. I hope y'all enjoyed your lunch. Just letting a few of us in here. All right, so we could take us into our check-in questions. I could check who's here. But welcome. Today is, let me double check. Yes, today is November 10th. Tomorrow, remember tomorrow's gonna be a holiday, so there's no classes tomorrow. And the next time we meet as AP is gonna be next week. So today's the last class of the week for us. And you do have an assignment due tonight. But sorry, I'm letting everybody in here. Let's go ahead and answer that check-in question right there. Do you like working from home, or would you rather be in school at the moment? What are your thoughts on that? All right, let's see. All right, we have home, school, mixed feelings with school, depends, either. Okay, so far so good. So there's like a mixture of at home or in class. At school, they're both kind of fun. Mixed, and either's fine. Same, just have mixed feelings about it. Right. Okay. Rather be at home. I'm sorry, rather be at school because home is where I relax. That's a good, yeah, that makes sense. All right. And a lot of us with mixed feelings like working from home because I have more flexible time. Mm. All right. Thank you all for sharing. Um, as far as for me, if I of course would, I think the best learning, of course, happens at school as a teacher. Um, the only part that perhaps I guess in the winter time that's hard was always going outside when it's super super cold. I would put on very ginormous sweaters and things like that. Now it's just cold at home, but I remember the classroom, my classroom, that heater really really worked. I remember it got hot on cold days. But so yeah, I do miss school, but I'm also like I'm not looking forward to getting up really early into the coldness, but I do think school is better. All right, so this is who I'm missing, y'all. Um, I am missing Kaylin with a K. Let me know if I'm correct on that. Yeah, I don't see Kaylin with a K on here. If any of you are friends with him, if you could let him know to come into class. We are missing Kaylin with a C, but he has reasons to not be here, so no need to contact him. But we are missing Kaylin with a K. But yay, most of us are here. Thank you so much, all, for participating in that check-in. Okay, let's jump into what we're doing as far as our agenda. So we just had our attendance check. We're going to be having some, I call them interactive notes on continuity. We're going to have a group thing with continuity, and I made the groups based the best way that I could. So you at least do have one person that you named, if you did name a preference in the form. I at least made sure everyone had at least one person that they work well with. If you said you had no preference, I just went ahead and added you in there. So that's going to be our group investigation. And then after that, the intention is to come on back and then we define the formal definition of continuity. And then we have our checkout question. So asynchronous number 8 is posted, and that one is due tonight. I noticed, I think like 4 of you have already turned it in. So that's awesome. But yeah, it's posted and due tonight. It was posted yesterday. And because of the holiday tomorrow, I'm not assigning any homework due Thursday. The next one's going to be due on Sunday. So it gives you more time to, work on financial aid stuff or CSU apps if you're still working on them and things like that. So yeah, let me know if anyone has any questions about this. But let's go ahead and begin. So actually today we're going to begin with a slight warm up, and we're going to just review limits a bit because I knew we only had like about one example kind of yesterday where we actually applied the limits. And I know that today's assignment is you practicing limits as well with the help and support of Khan Academy, because you could use the help buttons and they help you out. But I definitely want to just review some of this before we get started on talking about what is continuity. For those who had me last year, we did talk a little bit of continuity, but we didn't deeply like practice it as much as you do in AP Calc. So let's take a look here. So let's do some limits together. You can feel free to jump in the chat there, and I'll try my best to be aware if anyone's contributing. So it says there's an example of a graph there. It's going to be called f of x, and we're going to find these limits here. So the first one says, find the limit as x approaches 1 of f of x. So x approaching 1, I'm going to first identify it. And I usually like to do like a little dash line across where I'm looking at. It's going to be right here. I notice that along this dash, there's an open circle and also a closed dot. So just some things to notice. Okay. Now, because there's no plus or minus after the 1, that means the limit has to come in from the left and the right. So the left-hand side and the right-hand side. So again, because there's no plus or minus after the 1, that means the limit has to come in from both the left and the right. So to the right, we're going to imagine that the bug is like let's say right here. Again, I'm just using bugs. The bug can't jump, it can't fly or anything like that. So it's just going to keep walking on this path of the function. And it's going to keep walking and it's going to stop until it hits x equals 1. Basically, once it hits that dashed line that I drew, it's doing quite a travel, and then it moves up like a hill. And it's going to stop right here where this open circle's at. Remember, the bug can't fall down the open circle. And it also cannot try to like jump up to this closed circle. It ends up right here. And that y value it ends up at, it looks to appear that it ends up at 2. Okay, so that's the right-hand side. Okay, and then Rosa, you put 2. Awesome. And then now let's imagine the left-hand side. Maybe I should have colored this maybe in red. So let's do the left is in red. All right, so the left-hand side. So this is the common error first off. A lot of students would probably put the bug right here because this is a line that's on the left-hand side of the graph. But for limits, you want to start on the left-hand side of the dashed line. So we're starting over here, right here. So on the left-hand side of where you drew your dash. So that's what you want to be careful about. So the bug starts here on the left-hand side of the dashed line that we just made, and it's going to keep walking towards x equals 1, and it's going to stop there. So red bug also comes here, and the red bug is also going to end up at the same location, that same location being y equals 2. So because the left and the right hand side are equal, left is equal to right, that means the limit exists. Limit exists, and it's going to be equal to whatever number that was. In our case, they both equal 2. So our answer is going to be the limit as x approaches 1 is 2. So that's just a kind of a review on how to tackle these. So our answer is going to be 2. Feel free to like make a sketch of this so that you get your practice there on limits. We're going to go ahead and do the same process as x approaches 3. Let me clear up my drawings. Or let me know if I should pause in case anyone's copying this down. Whoops, I took out the 2. Here's 2. All right, the next one we're going to take a look at is where x is equal to 3. So 1, 1, 2, 3. So I'm going to do my dashed line. So for this one, I could kind of already tell where the bugs are going to end up at. But here's my dashed line. And again, when we're doing left and right, we're talking about left of the dash, and then the right side is the right of the dash line that I drew. So we're talking about right here. So on the right hand side, I'm going to draw a blue bug, and it's going to walk, walk, walk. Because there's no jumps or anything, it's clear that this bug is going to just end up at the same spot. In this case, again, y equals 2. On the left hand side, let's make it red. This is to the left of the dashed line, so the bug is over here again. And again, it's going to keep walking. And it's not going to fall in the hole. The bug is too big to fall through the hole. We'll say that. And it's going to keep walking until it stops at x equals 3 in this case. And it ends up at the same location. So for this one, again, we have that the limit does exist because the bugs meet up. And again, it's going to be at 2. All right. Let's do the limit as x approaches -1 from the left and -1 from the right. So there's something happening at those locations. Oh, there's something in the chat. Let's see. Did I mess up on something? Let's see. Oh, sorry. So Rosa, you said so left side is positive and the right side is negative. And yes, so when yes, that's correct. That would be the left would be like you put a little minus sign as an exponent after the number, and the right side it would have like a plus. Yes, that's correct. And then yes, the answer was 2 for this one, for that private chat. All right, so this one's saying as x approaches -1, and this one's saying from the left because there's a minus after the number. So this one, we're looking at x equals -1, which is at this location. So I draw my dash. Now this looks interesting because I see a break in my graph. So I know that I don't know if these bugs are going to meet up because there's a break. And I know they can't jump or fly. Okay. So again, let's go ahead. I'm going to do to the left of the red dash, and I'm going to do to the right here. So this one's just asking to the left of -1. So the only curve that's to the left of -1 is this straight line right here. So the bug is right here. And it's just going to keep walking until it gets as far as it can. And it's going to end up at this right here open circle. Let's see, I see something in the chat. All right, Viviana said 2. I agree with you. Yeah, that blue bug right there ends up at y equals 2. Perfect. A lot of 2's in this one. All right, now let's go ahead and, oops, why is it blue? Should have been red, but oh well. Let's make the right side, let's just, whatever. I hope y'all are following along, but I should have made it red because left was red, so that's why. Let me just take it out, it's kind of annoying. There, red bug, right here. Okay, now for the right-hand side, this is saying as x is approaching -1 from the right, because there's a plus symbol. So this one, I'm gonna make my bug blue. Now this whole segment right here is to the right of this dash line, but I'll just start my bug right here. Now this is coming in from the right-hand side. So bug is gonna walk, 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 and it's gonna stop until it can't no more. And because it can't fly or jump, it's gonna end up at a certain location. Where do y'all think this blue bug here will end up at? Let's see if anybody knows this one. All right, let's see the chat. All right, three of you are saying 4. I got a private chat, and then okay, a bunch of you are agreeing. Yes, you're right. The answer is indeed 4. This bug stops at the y value of 4, so our answer is going to be 4. Now, unfortunately, this problem doesn't ask you this right here. It doesn't say, so then therefore, what's the limit as x approaches 1? But of course, if you were to be asked this one, the answer would be does not exist because the left and the right hand aren't the same. But you weren't asked that, but just keep that in mind because the limit as x approaches -1 is different from the left and the right. It would be does not exist. So that's just there, but you weren't asked that, so I'm just making a note of that. All right, these last questions. Oh, let's see the chat. Yeah, yes, Edgar, you already got the D&E. Thank you. All right, so these last ones are actually, these right here are not limits. These are actually basic evaluation problems, similar to what you would see in maybe Algebra 2 or maybe pre-calculus, the beginning of pre-calculus. All right, and then do we already have an answer? Did someone say 4 for f of 1? Let's see. Okay, so f of 1, let me delete all my bugs because now we're not doing limits. This is just basically evaluating where your function is defined. That's basically what you're doing here for these last 3. And let's see, the chat was going wild a bit. All right, so 4 and then 1 is what I got in the private chat, and then Edgar said 4. So let's see, so f of 1. So basically that's asking you when x equals 1, so when x is 1 right here, what is y? So you go up and you trace your graph until you get a defined value. This open circle means the function is not defined there, so we have to keep going. This right here means the function is defined at this closed dot. So yes, we do get that f of 1 is indeed equal to 4. So those of you who said that, yep, you were spot on. And let's take a look. Yes, all right, good. So we got that. And again, if anyone needs us to re-explain it, let me know. Okay, maybe the one that might give you different answers are f. So f is saying, what is f of -1? Again, same process. We're going to find where -1 is. It's right here. And we're going to find where our function is defined. That means there has to either be a solid line through the point or there's a closed dot. So I'm just going to go ahead and find where this function is defined. We're going to pass through this open circle because this is not defined in our graph. And we're going to keep going until we get to the next one. So f of 1 is going to be defined at, let's see what anyone said in the chat. All right, so we have 4. Someone said in the private chat. Sophia said 4. Someone said 4 in the private. Yes. So f of -1 is indeed 4. And then lastly, we're going to find out what f of 3 is. Yeah, I know. It's like for some of you who already knew how to do these, sorry if it's a drag, but I definitely want to review it for students who haven't yet done the assignment so that you're not at a loss for when we talk about continuity. All right, last one, y'all. So f of 3. So when x equals 3, what is my function? So, okay, so usually we've been either stopping at a solid dot, but if there's a line, solid line through where you're stopping at, that also means it's defined. So it's defined right here. And let's see the chat. There's 3 things for me. Sophia says 2, 3 privately in the chat agree that the answer is 2. And yes, we are there. The answer is 2. There we go. So that's pretty much, again, a review on how to find limits, and not only limits, but also how to evaluate a function using these funky graphs. And these graphs, we kind of sometimes call them piecewise graph because they have like open circles, they have closed circles. And maybe you want to put a note in your notes that open circle means your function isn't defined there. Closed circle means it's defined. A line also means it's defined. So those are just some notes on how to do this. Let me just pause a few seconds to see if anyone has any questions. And if not, we'll move on to our discussion on continuity. Now for the next portion, it's okay if you didn't copy this down, but once we hit our notes, it's gonna be the next slide. You wanna be ready to copy it down. If you copy this down already, that's fine. I mean, that's more helpful to you to copy this down or for you. All right, let me go ahead and clear up this page. And let's head on to our notes, the notes for today, which is continuity. Let's go ahead and write this down in our notes. The learning target is I can understand and apply the formal definition of continuity. Let me give you all, I don't know, like 45 seconds or so. All right, a few more seconds. All right. So today's talk is going to be on continuity. It's also going to be the focus of the group work as well. The learning target is I can understand and apply the formal definition of continuity. So here we go. So what does continuity mean? Another way to say it, I think continuity is the noun, continuous is the adjective. So a function is continuous if the graph of the function can be drawn without lifting your pencil or your finger from the paper. So if you're tracing a graph and you don't need to lift it at all, then it would be continuous. This is an example of a continuous function. This right here is a piecewise function. It's defined piece by piece. And its graph looks like this. So for this particular piecewise function, it actually has no breaks in the graph nor holes. This particular piecewise function is continuous. And if I was like to trace it with my finger or a pencil, let me use this drawing tool. So if I was to trace this function, I would have a nice smooth trace. I wouldn't have to lift my finger because all parts are continuous. It's nice and smooth, no jumps, no holes, no gaps. This means this is a continuous function. Oops, sorry, let me keep it here. Let me let you all copy this down. Just an example of what is continuous and what do I mean by tracing it. It means you can even think of that as like you can highlight the graph without lifting the highlighter too. All right. By the way, y'all, I do have the slides on Google Classroom just in case if you need to go back to get something down. They're on there. And if anyone needs the video recordings, just feel free to request it. Because I always record all the lessons anyhow. All right, let's move on to the next slide. So I'm going to clear this. Now, the next slide is, I think it's additional examples of continuous functions. Now, you all as math students, I think you're very used to working with continuous functions. Like piecewise, like functions with holes or gaps might be something that's new. Like I know we've looked at them in pre-calculus. I don't know how much y'all looked at them in Algebra 2, but in general, we're very comfortable with working with continuous functions, and these are all examples of continuous functions. There's wavy ones, like a sine or a cosine wave. There's lines, those are continuous. I don't know what this is, but it's continuous. This one right here, I believe it's an absolute value function. It's also continuous. Um, they don't have the little arrows drawn at the bottom of them, but of course you can assume that these functions go on forever and ever. So these are here some examples. Let me give you some time to quickly sketch these down. All right, I hope you all got that. These four just quickly sketched is just for your reference, like what are continuous functions? They're the ones you're most used to. And now let's go ahead and talk about, well, what is something that's not continuous? So when the values of a function are not connected, as in the function to the right, well, it's not really to the right, it's going to be to the bottom, we say that it's not continuous. So this right here is another piecewise function, and its graph looks like this. So if you were to hand graph this, or if you were to use Desmos, the graph would look something like this. Again, when the values of the function are not connected, notice how there's a break in your graph. Another way, of course, to think of it is, again, if I try to trace this with my pencil or with a highlighter, I would have to like pick up my highlighter or my pencil in order to trace the graph. For example, I could start right here and I start tracing my graph, like here's my graph. Then I have to pick up my highlighter to trace the other portion of the graph. So because I had to pick up the highlighter or my pencil or my finger, whatever, that makes this not continuous. So this is an example of a non-continuous function, and I'm going to also show you more examples of how they look like in their graph. So this is just one. I call this a jump discontinuity, or we call it in AP Calculus a jump discontinuity, because like you would have to imagine that, like for example, the bugs would have to jump from one point to another to get there. So this is called a jump discontinuity. Yeah, when something's non-continuous, we say discontinuous. So that might be a new word too. So I'll just pause here for y'all to copy this down. And feel free to ask any questions. I'm happy to stop and elaborate. Do we copy the graph too or just the note? I copy the other graphs. Yes, I would copy the graphs so that you have that visual example in your notes. Yes. Just copy a graph that shows that there's like a break in it. Oh yeah, and I should also, I mean, I haven't been collecting notes, but I think I should. I mean, it would be nice, like easy credit for y'all too. Um, Perhaps I'll let y'all know, but I'll let you know beforehand rather than surprising y'all. LOL, Rosa. Just make sure you're taking your notes though. But I mean, I'll let y'all know at the beginning of notes when I'll be collecting them. It's easy credit, so it's nice to just get some credit in for following along. All right, so we talked about an example of a non-continuous function. Let's look at some more. There we go. So these are the different types, and I believe that includes all of them. I hope. I think that's all I remember. And again, in the AP exam, they do, like, sometimes in the multiple choice, they're like, what kind of discontinuity is that? The first one is when you have a hole. You can have just a hole without the dot, or you can have something like a hole and a dot. That's called removable discontinuity. It's removable because it's like if you were to fill in this circle, whoops, if I was to fill in this circle and make it defined there, then this function would be continuous, but it's not. So that's why it's called removable discontinuity. This one, as I mentioned before, whenever there's a break or a gap in your graph, we call it a jump discontinuity. So this one you definitely want to write down. These are important definitions. The other one that we probably rarely had exposure to, like I know I talked a little bit about graphs with something called an asymptote. That's these dotted line right here, an asymptote. But you don't have to know exactly asymptote right now. I'm just saying that's the name of this. But this is called an infinite discontinuity. That's because this graph infinitely approaches this asymptote to the right, and this approaches this asymptote to the left. Notice how our graphs, though, the y values don't ever meet up. Thus, this is a discontinuity. You can also see that it does look like a break in your graph, though. You would still need to lift your pencil or highlighter to trace this graph. So this is called an infinite discontinuity. All right, for surely you want to get these examples plus their names written down. Sorry about that, y'all. I hope y'all had enough time. If anyone's like really feels rushed, just let me know. But again, slides are on Google Classroom. Let's go ahead and move on to the next portion, which is, all right, so now we're gonna soon go into our breakouts. We're gonna be having 4 groups. And again, I definitely tried to pair you up to the best that I could. So we're gonna be now trying to figure out the exact definition of continuity. So in mathematics, we can't just say something's continuous just because I don't lift my pencil or my highlighter. Um, so that's not enough in mathematics. Mathematics, we need to be precise with our definitions. So we're going to try to investigate this with our groups. Now, in your groups, you're going to be filling out this table with respect to this graph. So the definition of continuity does involve limits. So that's why you're being asked some questions about limits here. It also involves a function being defined or not at a certain point. So I would copy this down because I'm going to be doing some of these with you. I think I'm going to be doing number 2 and number 4. And as a group, you all will finish this up, as well as some follow-up questions. So I'm going to be doing this one. Oops, nope, I'm going to be doing number 2 and number 4, just so y'all understand how to read this table and how to fill this out. All right, so first thing. So here's A. These are your A values. So that's what they mean when they say, for example, as x approaches A from the left. So this one's going to say the limit as x approaches 2 from the left of f of x, and it's going to equal to something. Maybe. Left one should exist. So here's my 2. I could do a little dotted line if it helps. Oh, it's going to be kind of hard to see, to be honest. This is going to be an estimate. I'm going to try to use a straight line. So because this function is fully connected, the limit from the left and the limit from the right are going to meet up. So the bugs will meet up. Now I just need to determine what y value is this that they're meeting up at. Would y'all think that's 3.5? I hope we're okay with saying that's 3.5. My line looks a little crooked. Okay, let's just say it's 3.5. So I guess we're gonna have to make some estimates. All right, so that's the limit as the bug is approaching from the left. So that's like imagining the bug goes down here and it comes and stops right here where x equals 2. Then we got to do the right hand limit because now it says the limit as x approaches 2 from the right. X approaches 2 from the right. And again, because your graph is fully connected there, it should be equal to the one from the left-hand side. So the bug could be over up here, crosses over a hill, but eventually he's still gonna end up and meet up the bug at the same location. So that's gonna be 3.5. Because the left and the right-hand limits are equal to each other, that means the limit is defined and it's going to be the same as the left and the right, which is 3.5. Let's see what's in the chat. 3 from the left at 1. 3 from the left at 1. Oh, you're answering for number 1, Rosa? That'll be awesome once you hit your group. So this one's going to be the limit as x approaches 2. It's going to also be 3.5. And then lastly, this one here, it's saying f of a, because the a we're looking at is 2. They're asking for f of 2. So when x is 2, what is my function value? So again, because there's no holes or anything, there wasn't any, let me show you, erase all this. Because there's no holes or anything like that, at x equals 2, it's literally going to be the same thing as the limit value in this case. So this, it's still going to be, why doesn't it not look like 3.5 anymore? Well, I'm going to keep it at 3.5, so there. You could just do an estimate. I don't know why that looks so horribly off. Let me use my straight tool. No, okay, it does. Yeah, this is so weird, right? I think it's still going to be the same, of course, so 3.5. Thank goodness, because I feel like I did that really bad. There we go. So that's how we filled out the table using 2, x equals 2 as the example. Let's see what's in the chat. That's okay, Rosa. Then you're going to get to working with your group. So that was just me doing an example for the second row here in the table. I'm going to now do number 4, and then you all are going to get to finish this in your group and answer some follow-up questions. So don't worry, you're going to have the support in your group and try to sense make all of this. All right, I think I specifically chose to do number 4 because number 4 has this. It has this infinite discontinuity, so that's why we definitely wanted to do number 4 so we could talk about it. Okay, so this is going to be the limit as x approaches 4 from the left. 4 from the left. I don't know if any of y'all know what the answer would be for that one. Maybe you could put it in the chat. So that means the bug is to the left of 4. Here's my bug. And it's going to just keep going up on this curve. It's going to keep going up and up and up. What would be the limit of that? All right, so privately someone said infinite, Edgar said infinity. You're both correct. The bug is just infinitely going up on the y. It will never stop. It will never meet its location. It'll just keep going forever, which is kind of sad. So I'm just going to put infinity. All right, so that's for the left. Now let's look at the right-hand side. So the limit as x approaches 4 from the right. Well, I think you see the same thing happening from the right-hand side. From the right of 4, the bug is going to start here, and then likewise, it's just going to go up forever. So they'll both never meet up because they're on this crazy path that goes like that. So this is also infinity. So then the limit that as x approaches a is going to just be infinity then, because they agree. So let me also give you all a note though. Quick note is that in the AP exam, sorry, it's because my tool doesn't let me write it, but the answer for this one's infinity. I can't get the tool out the way. Just so you know, in the AP exam, maybe I'll write this at the top. In AP exam, infinity is sometimes D and E. So you want to write that down. The reason for that is because infinity is not a number, right? It's a concept, not a number. So that's why in the AP exam, sometimes the answer for these would be D and E because infinity is not a number. So that's just something to keep in mind for these ones. Lastly, y'all, let's see what y'all think. So what would be f of a? What in the world would my function be defined at x equals 4? So at x equals 4, that's this dotted line right here. Oops. I need to find either a solid dot or a line on the graph. I mean, so far I'm tracing and I'm not hitting any line, I'm not hitting any point. So what do I do? Yeah, Edgar, you're right. So because there is nothing there, either if you have an open circle or if you're on an asymptote, the function value is going to be does not exist. Or you could just put NA, whatever works with you. You could put DNE or NA, not applicable, /NA. All right, so this was a walkthrough on how to fill out 2 rows of this table. So you're going to be going into your groups. You're going to finish up this table to the best that you can, given our time. And then we're going to come back and just talk a little bit about your work. Please, I hope you got this down so I could clear my screen and show you the second part of this. The second part is the sense making part. So this is filling out a table. The next part, you're going to be asked these questions at the bottom. You're going to be asked relating the continuity of the function, whether the limit exists and so forth, or whether the point exists. So you're going to try to discuss this with your group. And how the breakout groups are going to work is that I'm going to give you the document. Y'all are going to decide. I'm going to put this in the chat. Y'all are going to decide who's going to be the one sharing the screen. You could do it by birthday, by age, by favorite color. I don't know. Whichever way y'all can decide. And only one person needs to share it with me and put everyone's group names on it. This will be for credit. And we'll see. We might not finish this today. But if not, we're going to continue this on because continuity is super important for calculus. But let's just get a head start on it, everybody. So let me stop share and let me make everyone's group. Give me a second. It's going to take me a bit. All right, you should have received a join message. Go ahead and join your group. Make sure you got a copy of the handout though. Join your groups. Join your group. Evie, do you see a join your group thingy? Okay.
Wait, how do you see what she sent?
She put it in the chat.
Oh, there you go.
Her again.
Thank you.
Welcome. Just making sure everyone can share their screen. I'm just gonna jump group to group.
Listening in class, I was literally laughing as
Hello,
well.
Mr. Dono.
Hi.
Oh, hello.
Hi, y'all. I'm putting the document back in so y'all can get started on it. Make sure to share me. Whoever y'all are gonna agree is gonna be typing out the stuff.
That's not gonna be me.
I think we decided Evie, you know.
Okay, hold on.
Mr. Donna's Sophia sharing her screen. She's just trying to open it right now.
Okay, I also put it back in. I was also making sure y'all can share the screen, but I think you could now. I don't think you were allowed to.
Before. All right.
Could we
Mr.
make
Donna, I
a
have a
copy
question.
of it?
Yes, make a copy, please. Yeah. Oh goodness.
Mr. Donna, I have a.
I'm writing you guys' name.
Okay, it's good. It's good.
Yeah, make sure. Oh, hi everybody.
Hello.
I think I gave y'all sharing access in case you were trying to figure that out.
Yeah.
Put equations in Google Docs, right, Sophia?
Huh?
Isn't there a question? My bad. I know. What was the question?
Oh, I was just saying, when we like do the work, we fill it out for like all of us, right? And then we put our names. Do we share it with you, or is there gonna be an assignment on Google Classroom where we put it
Just
in?
share it with me. Yeah, I didn't want to fill up my Google Classroom with too much. So yes, you're just gonna share me.
Got it.
Perfect. And then you probably are just gonna get started on this and make sure you make a copy because I think I gave you all the original doc.
Yeah, I made a copy.
Perfect.
Put our names on it, Sophia, like in front of it.
Okay. Hold on.
Already, Roxana?
No. Which one did you finish?
What do you mean?
Oh, you didn't finish? Or which one are you working on?
Isn't it the CSU's one?
Are you applying to UCs too or just CSUs?
Both.
Lit. What about you, Fernanda?
Hmm?
Are you applying to both?
I don't know yet.
Wait. Oh, wait.
Wait, what? Bitch, what? I'm confused.
Cause if
I like how Mrs. Donald just sipping on her drink.
Just listen. Yeah, make sure you share me on this doc, whoever's typing.
Oh yeah.
Wait, where's La Linea? Like, when do we see what's the left side, what's the right side? You see, it's why I need help, bro. Because I swear to God, I'll be feeling dumb up in this class.
Try and see if you could use whoever's drawing, if you could use the annotation tools.
It's cold.
Mr. Dono, which one's your email again?
Either one, actually. I don't know why it's
okay.
like that. Yeah. Great. So, James, you're about to explain something, right?
Well, oh yeah, for the first row. Wait, let me fill out the ones that you did, Mr. Dono. Do we have to write the lim function, or can we just?
No, don't worry. Yeah, you could just write the answer. I just put it there so y'all understood what the A was. All right.
For
So
2, there's one in between. Yeah. Okay. Well, how did you get 3.5 for 3?
Well, that's what Mr. Donald did.
What?
Mr. Donald did that one.
that was the one I just did in class.
But how come I got 3-1? I'm feeling dumb.
3-1.
I got 3 and the Y value was 1.
You got 3 and the Y value was 1.
I think we're not looking for Y values.
I'm confused. I don't get this. Nothing ni
Okay, so basically, when X approaches negative 3.
James.
Yeah.
The 3.5 was for the second row. That's
Oh
why.
yeah, huh? I'm sorry.
That's perhaps why that was a little confusing.
I was
Yeah.
like, hold up. I know I'm not. I'm like, I'm dumb, but not like that.
You're not dumb, Rosa. That's why you're in here. Remember, you wanted to so badly be an AP Calc, remember?
Yeah, because I was like, I think I've done this last year, but clearly my school was just ass. Madison can't do anything right.
That's okay. We'll learn. And plus, the assignment that's due tonight.
Yeah, I was working on it, and I kind of got one of them. I'm just confused. Like, I'm
Okay.
just get confused when it comes to like the table.
Yeah.
Miss O'Donnell is our first row, right?
Okay, let's see. So can someone explain why you got D&E for the first one?
Number neta, I'm gonna try to explain it.
Okay.
I think we got D&E because if we're doing it from the left side, there seems to be like no value.
That's my explanation too.
Yeah, and then we got positive too
Left-
because
Left
one-
side one, right? We're talking
yeah,
about one. So can
Yeah.
James, are you able to do a dotted line? On the
yeah,
line?
they're confusing me.
I don't think so.
No, you're not able to use annotation on Zoom.
Press on the thingy on the marcador, the one next to the A.
What do you mean next to the A? But that's highlighting.
That's why. Just do that.
If you
Use that
can
to
highlight?
press up and down like a vertical thing or something.
No, but that's just to highlight the box.
Oh, okay. Okay, so I will hopefully let's try to explain this. So imagine there's like a vertical line, right, through x equals
Mhm.
1.
Or do you want me to do the PDF thing, Miss O'Donnell, the one that you did from the
Oh,
first module?
You could, but due to timing, we're just gonna get started on this, so we're gonna have
Okay.
to do this next time. But let me just okay. So at x equals 1, y'all notice there's a hole there, right?
Yeah, so ¿qué significa eso?
Mm-hmm.
Oh, that's the hole. There's a thing in the hole. The hole's gonna drop in it.
It's
So
not
just
gonna
be
drop
looking.
it. What was that?
So because there's a hole, there's technically no point there.
That's
So
correct. That's
it'll
why,
be D&E. That's why it's
yeah,
D&E.
that's why that last
hole.
one, the one that says f of a, that one is DNE.
And
Oh,
that's
'cause
for
it's a-
three for
it's
three
an
minus
open
one.
circle.
It isn't 3 at 1. It's 3 at 2.5, right?
It's 3 at 2.5.
I'm on 3.
Oh, you're on 3. I was talking about the first
The
one.
first row.
Yeah, because
First-
there's a hole. It's gonna be D&E. It's gonna be does not exist because there's no point.
She's doing this one, I believe.
Oh, okay. Can you click on the box that I was talking about, James? I was
This
talking
one?
about, yeah, that one. We're talking about this one here. The rest of the table looks good, except for this answer. So,
Okay.
how did y'all get 2 for as it approaches 1 from the right, though?
Right.
You see, James, you guys out here looking stupid, bro. I'm just kidding. I'm just kidding. It's a joke. It's a joke.
Because you're right. The answer is 2 there. But how
It's
did y'all
because
get 2?
so basically, the point would start from, I don't know how to use the marker tool, but it would start, I don't know how to do this.
That's okay. But you
No.
can verbally explain it.
Well, where it says where the 3 is, where
Mhm.
the closed circle is,
Yeah.
that's where you would start from the right and work
Bug
yourself to
swap.
1.
And it
Uh-huh.
stops at 1. And where's the bug at?
And it's at 2.
Great. Using the same logic, do the same thing you just did for the left side of that or open circle.
Ando pero bien confundida, la verdad. Oh, isn't it gonna be 2 as well?
Yeah.
Because it's
Yeah.
coming
So the bug
from,
does
from
not.
down there.
Mm-hmm.
It's going up until 2.
Yes. And
Okay.
the bug does not fall down the hole, right? Bug is going to be on top
It's
of
gonna stay on there, so it's gonna be at 2. So that's why the first one's wrong.
That's
It's
correct.
supposed to be 2.
Yes. There we go. You got
This is
it.
2?
Yeah, it's 2.
Oh, if it approaches, okay, I see.
Mira, no soy tan estúpida. I'm just kidding.
You're not,
Oh, but you gotta chill.
girl. All right. I'm going to close up the group. So make sure you shared me. I'm going to bring everyone back because we're almost done. All right, y'all.
Really? That was fast.
Oh, hello. I'm just waiting for everybody to come on back. Hey, everybody. Just waiting for everyone to join us.
I had a question.
Oh, yeah, go ahead.
Should we include our answers from the work that we did with you as well, or?
Yes. Yeah. So I did row 2 and row 4, I believe. So you want to just put those in as well. And I think I got the copies of 2 groups. So I just got James's group and Sophia G's group. So if you didn't share me yet, if you could please share me. I didn't get to bounce into every group. So again, most of the groups we're filling out this table. So we're going to go ahead and continue our discussion on continuity for next time. So it's okay if you all just barely got started. For me, it's enough that y'all already started talking about it because that's where the sense making comes from. So again, just make sure you share it with me because I'm missing two groups work. So I could give you some credit for today. So quick checkout, y'all. Yeah, I think I got one more. Quick checkout is going to be what questions do you have? So right now, or maybe you learned something about continuity, like the basic definition, or what questions do you have? Go ahead and put that in the chat and then we'll close up our class. All right, that's a great question. How do you see what's on the left side and what's on the right side? Yes, and then I saw in Rosa's group, there were sense making about like, how do you do those problems and then what's the difference whether there's a hole or not? And then no questions, yay, no questions, that's awesome. No questions, all right. The same, the same smiley face. I got more clarity. Sophia bullied me. Were you guys in the same group? I'm uncertain about these groups now. All right, no questions from Edgar too. All right, anybody else? So any questions or anything learned about continuity? I mean, the groups I was in, it was great. I'm sorry I didn't get to go into every group. No questions. All right, Gracia says Sophia was nice. No questions. All right, a bunch of no questions. Okay. All right. Thank you, Israel. A little bit more understanding. Y'all be nice in the chat. I'm going to start being in that group then, y'all. I'm going to be in there, making sure there's nothing. All right, y'all. Class is over, so y'all have a great day. I look forward to seeing your asynchronous work. Don't forget about it. All right. Bye, everybody. Make sure you share.
Bye.
Bye. Y'all have a good day. Bye, y'all.
I have a question
Oh, yes. Go ahead.
for the task that we were given. Or we're supposed to complete that today, right?
No, don't worry about it. We're going to continue the group work on, I guess the next time we meet is going to be Monday for this class.
Oh, okay.
You could if you
all we finished was the table.
That's totally fine. That's where most groups, because you only were there for like a few minutes, so that's okay. Yeah, most groups got finished only with just the table. So I'm thinking on Monday, I'm gonna pop open with starting with the table, and then I'll release you all back into your groups, and then we'll finish our talk on continuity. But if you want to, like, feel free to work on it independently and just bring your ideas to your group as well.
Okay. And I had a quick another clarifying question. So it was like it said like F of 1, and there was a hole there. Wouldn't that be D&E?
That's correct.
Okay.
Yeah. Hole would be the functions undefined, unless there's a dot. But
no, there was no dot. It was just a hole.
Okay, I'm taking a look at your table right now. Number 1 looks good. I think were you talking about number 3?
I was talking about number 1 for F of 1.
Oh, F of 1. Yep, you're right. It looks all good.
Okay, cool. All right.
Awesome.
Thank you.
You're welcome. I'll see ya.
We'll see ya.